Um, Thanks for attending today. Today we've got a pretty interesting topic for you, and that's in the Extracting Value series, and that's point cloud alignment within a virtual design. Um, this features a new tool that we've developed over the last few weeks, and we basically allow you now to move point cloud between coordinate systems. And as I was saying, what we noticed in our work with our customers is that this data is flowing down to surveying, and from surveying and mapping down to design, engineering, and construction operations. And there exists a need to align models and point clouds between coordinate systems. And as the example we're going to show you today, we're going to show you some detailed point cloud and models of precast bridge beams and how they can accurately be aligned within the virtual design for analysis and basically looking for all those things you want to know with clash detection, analysis, fit, and that's really, really powerful. So we think this we're very, very excited about this new tool and this new capability. We think this is going to open up a lot of applications for our users. So without further ado, let's move along. Okay, so once again, just for anybody that's new that's coming, let's just tell you who we are. That's Ted Mack, and I'm president of Certainty 3D. You've got Matty Turnius, he's a lead software developer, and he's going to be showing you how this works today. And of course, Lindsay Messer, our sales manager, is always here to help you and get what you need and to help solve your problems with any products we have that are applicable to what you need. So, moving down. We always like to go to the big picture. So the bottom line is, why are you doing this? So as we said, LiDAR data flows to downstream operations. And when we call downstream operations, we're kind of moving out of the survey and mapping and letting that data flow to construction, to design, to engineering. And as that data flows down, you've got this requirement that you really got to move point clouds between coordinate systems. And basically what that allows you to do is to virtually assemble structures within your design. And virtual assembly of structures within the design saves big money. Let's just put it as a big return on investment, because you can analyze large pieces or small or whatever you're moving, whatever model or point cloud you've scanned that exists or model you've designed, you can move it into that into the virtual scene, and you can analyze how that's going to fit and how that's going to work for you without any transportation costs and without finding out on site. So the problem, let's just show you what we have here. We have a rather sophisticated bridge design, and within that bridge design there are prefabricated beams, and they have to be evaluated, and basically they're sitting in a yard somewhere, and the question is, how do they fit into your virtual design? So let's take a look and see what we've done. Well, obviously in the left image you've seen how it was probably a mobile scan was done of the area, and you can see how the design now fits within the mobile scan data. But the bridge, prefabricated bridge sections are in a yard somewhere. They're prefab. They're sitting there alone, so each of them is in their own little world, their own little isolated coordinate system. Okay, so the question is, how do I get those into my virtual design? Well, let's take a look. Within the virtual design, we turn off all the point clouds in both, and what was done to these basically there was a design point, attachment points within the design where the beam was going to sit. Of course, on the right, and so on the left image, you see basically P2 and P3. P2 is the actual attachment point. P3 is a point basically directly under it, and basically those same points are then identified in a model of the point cloud, of the beam point cloud. And the reason we do that, for all the reasons. I mean, everybody knows how to model now, hopefully. If you don't, give us a call. But cut cross sections, fit your slice, and basically make sure that point is very accurate within the point cloud. So basically we use this model to define P2, and again in this case P3 is just defined below it at a fixed height. Okay, and you'll see, and that same instance is done on the other side. So basically what you're doing is 3 or more attachment points. I mean, you like to have 4 or 5 or 6 or however many you need. Now once you define that attachment point, you can basically just use you don't have to use the model anymore, you can just put the point cloud. So here you have the point cloud with point P2 and P3. Okay, and again, so this point P2 and P3 are going to be on one side of the beam, are going to be attached to point P2 and P3 on the attachment point in the left view. Okay, and of course the same thing is happening at the other side of the beam. Basically, the TopoDOT alignment tool will just do this for you automatically. You'll just select, and Maury's going to show you later how you just basically, you can identify the corresponding points. It can actually find them automatically if there's a good structure to it. Of course, if they're, if they're symmetrical, you want to basically tell it which ones are which. But in any case, that point cloud, the model will basically just pop right into the virtual alignment. It'll be a least squares fit between those attachment points, and you will get a report on those attachment points, a least squares report on how accurate and what the error was between, a least squares error between those attachment points. So you can actually get and analyze your fit at the attachment points, and of course within the design, you can see how it fits. You can start evaluating clash detection. You can see if you can move you can design other virtual pieces to go in there. I mean, anything you want to do. So the nice part about this is with very little modeling. I mean, we showed you a full model of the beam, but you don't have to. You can basically, just as long as you identify your attachment points extremely well. And again, don't click on points in a point cloud. You've heard us say that many times. Cut a cross section, put in your cell that defines the cross section of the beam, for example, and say the midpoint of that cell, that midpoint of that line is where you want to attach, and it'll be much more accurate. But having done that, you can put the whole point cloud in. And if you'd like to model that point cloud, great. It may not be worth the time. You may be able to just use that point cloud, because the point cloud is like a 3D picture with all those points representing the spatial spatial representation of the beam. Okay, so this prefabricated beam alignment and the bridge design. So okay, so what we're going to do now is we're going to demonstrate this. We're going to show you a little bit of extraction of the attachment points and with demonstration of the alignment tool. Okay, so and I want to just point out to our friends at Hewitt and HNTB, thank you so much for letting us use this data. Once again, it's always great to work with good customers, and we're very grateful when people provide this kind of excellent data, this real life data, so we can use it and develop our tools around real applications. So so basically a shout out to our friends at Hewitt and HNTB. Thank you very much. Okay, well with that we're going to turn it over to Maury, and Maury's going to show you how this this tool works.
All right, guys. So just to get started here, like Ted mentioned, we have here our design bridge and roads and stuff, and we have all the beams here that were scanned at the casting yard. All right. And the process here is going to be just like Ted explained there. We're going to come in here, and we want to find the areas where we want to use as like attachment points on both the data sets. So I'm going to do it in my casting yard, and I'm going to do it where I want to place it in the design. So I'm going to go ahead here and just turn off these things. Oops. All right. And then I'll just come in here to my top view. So we're going to do here this this blue beam, and what I'm going to do is go ahead and open up this least squares fitting tool. And we're going to come in here and we're going to identify these points. So I'll just click that identify. We're just going to click here. We can specify a name that we want to give that point. I'll just leave it there as 0.1. I'll come over here to this other side, do the same thing. So we have there 0.2. And then I'm also going to come down here to the bottom, and we're just going to place a third point there, just at the bottom of that abutment there. All right. Once we have that, then we're going to come over here back to the beam itself, and I'm going to start identifying this with points as well as object 2. So here we have a center line running down the beam, and then these lines coming across are where the intersection of these two is where it should meet up with this point here. All right, so I'm just going to go ahead here and snap to the intersection of those. All right, but we still need our third point on this particular data set. So what I'm going to do here is basically just to make sure this is kind of coming in vertically, since we don't have a third point, I'm just going to come in here and just define a third point by looking at the offset of these two. So I'll just go ahead here and move that line over, right over there, and then just define that same 0.3. Okay. Once I have that, then I'll go ahead here to this Generate Transformation tab, and I'm going to specify here that the minimum amount of points I want to use is 3 points, since that's all we have here for this data set. And I can come in here and link each one of these manually, or I can try this auto link button, which is going to do just basically try and find the best fit for those results. I can come in here and click this next result, and it's going to try giving me a different option that it found based on the tolerances we specified here. All right, and then basically once I have that, it's also again giving us those deltas based on the fit of each one of those points to each other. And I can come in here to this next tab, and I can start giving this a try. So I'm going to say here that I want the object 2 to copy over here to this area. All right, and you'll see it's going to be coming in just like it should, with the points there sitting on top of each other. What I can also do is we have the scan position data for these beams as well. So if I come in here, let me pull in that data. So we have bridge 1, girder 4. I can also specify here that I want to move the point cloud and apply that same transformation to it. So I can do that, and then we have that right on top of the area as well. All right. So basically, that's kind of the way you use the tool there. Anything you want to mention here, Ted, or anything you want to?
Sure, exactly. Yeah, this is a pretty straightforward demonstration. So I don't think it won't be long today. But you see how basically the transformation is it's a least squares fit transformation, and you have the error. You can use multiple points, and you don't necessarily have to identify corresponding points. In this case, we only had 3, so it could have found 2 solutions. But if you had 5 or 6 or whatever, you could basically move the point cloud anywhere you'd like and do a best fit. The key here is when you basically, if Mally just turns on the design, you've got that beam within the context of your entire, either your scan, your design, and basically for analysis. So you can look at clash detection. You can look at there you have the beam. There you have the so there you have the Mally's turned on the data from the data from the existing data. Thanks, existing bridge. I lost my head there. And the other thing to notice too is that if you might have noticed, the model wasn't exactly at the ends. It wasn't exactly modeled as tightly as the point cloud was. They basically, the structure, but it kind of had a funky end to it. And that's okay, because in the end, when you take the point cloud in, there's no reason to model the entire beam anymore. Actually, the model was actually a residual from the first attempt they did at this. I think the guys at H&DB had to model the whole thing and then move it. So they actually made a precise model as they could. But really, you don't have to. I mean, you can take the the point cloud in. I mean, obviously it has all the rebar, everything else there. So let's show that for a bit. Now let's just show that beam in there with the rebar and everything else that's coming out of it, the point cloud.
Mm-hmm.
And so you can see that in view 2. And that'll just give you, obviously analysis, and this is pretty obvious what you can do and how powerful that is. So where are we? There you go. So now he's got so we can make the model go away and just basically turn on the point cloud. Mm-hmm. And there you see a cross section in blue. It's a little hard to see, but if you turn on the entire one, there you go. A little heavier, so you can see now you actually have the cross section there. You can do cross sections along the beam. In view 2, you see how that beam in that particular area, how that looks. If there's any interference, you actually see the rebar coming up through where the scanned area is. And make your decisions. So it's a very powerful tool. It's very easy to use, and I think it's really going to open up a lot of applications for you. So I think at this time, if there are any questions, let's open it up. Anybody have any comments, feedback? Let us know. Lindsay, how are we doing? You see anybody with their hand up?
I don't see anyone.
No. Okay. Oh, either everybody just extremely impressed and just says speechless, or we just did such a good job. Oh, there's Ken Crawford has his hand up. So let's talk to Ken. Ken, how you doing?
I'm doing great. Can you hear me okay?
Yeah, just great.
Oh, okay. Yeah, my question on this was, first of all, it's great to see that tool, but do these, the models that he built and then brought the model over, copied the object and all that, and then he, of course, brought the associated point cloud. But do those have to exist in the same model in the microstation file, or can they come from, a different model?
Sure. So Mally, why don't you mention where that comes from? Yeah, it can come from any file, any project, but sure. Mally? Would you bring them in as a reference?
What I did in this particular case is this was actually there was 3 models inside of this DGN, and to bring in the casting yard, basically I just referenced that to itself and just pulled in the model itself. So it's actually sitting further away over here in the drawing.
Yeah, it's all in that 3D design space there. Then that is a single model. But could that have been a separate? And by model, I don't mean the part model. I mean the DGN model.
All the casting was a separate model, but in order for me to plot out the points that I use with this tool, it needs to be in the same model itself.
The same model space. That was my question. So that took care of that. That's great.
Okay. So all right. Anything else, Ken?
That's good. Thanks.
Okay. So you think you can use it?
I can. I don't have a project on it right at the moment. I'm still struggling with getting my feet wet on some of the other stuff, but I always like to stay on top of these.
No problem. Okay. Is anybody else? Anybody else out there, Lindsay?
I don't see anybody.
Okay. Well, if there isn't anybody with their hand up, go once, go twice. There's a.
See. Mike, Mike Pfaff, did you have a question? I'm unmuting you. Okay, no, he didn't. Nope, that's it.
Okay. All right, great. Well, okay. No, I think it's pretty self-explanatory. Obviously, you can align point clouds. You can do a bunch of other things too. Be careful when you're doing topographies. Don't shove your point clouds around. Just try not to lose the integrity of your data when it's actually survey data. But in applications like this, obviously when you're scanning precast beams and the things, that's acceptable. You're going to have to move this precast beam into your design. So it really opens up the synergies, and it lets that data. And what really happens, and I'm just going to real quick, and we're going to let you guys go then, is what really happens is that you can do that analysis of the element within the design, and you're basically saving money. I mean, obviously, clash detection, fit analysis, and you're identifying problems for shipping, construction, and you can imagine what the cost of just in this particular case of moving that beam putting it up there and finding some clash or something that didn't fit before when on site as opposed to virtually on your desktop. The other thing is, of course, the alignment tools are user-friendly, intuitive, and they're very accurate. So I think you'll like the alignment tool. Give us a call, if you need any training specifically on it. Show my screen. Oh. Okay, sorry about that. So I went through a few things without. Now I really messed up. Okay, forgot to turn my screen on. So basically, what I was saying is, the alignment tools are friendly. It's pretty easy to use. And what actually happens is alignment tools add value to your data. I mean, right now, your data starts to have a place from surveying, mapping, and topographies. You can take your data into design, engineering, construction. So keep that in mind when you're talking to your customers, and keep that and tell them you have this capability, and it'll just start the wheels turning. You feel free to show them a little bit of this with this video, and I think it's it'll be beneficial for everyone. So that's it. Thank you very much, and if there aren't any more comments, we'll call it.